Okay, so they give us the coordinates of some points, so we have to label those. F is 0, 12. G is 5, 9. J is 10, 6. K is 15, 9. And P is 20, 12. Now, that function does not have an X and a Y axis drawn for it. We need to think about where the X and the Y axis would be and how we could label those points, right? So, where does my Y axis go? It needs to be vertical. Where should it be? It'll go through one of these points. Which one? It'll go through F because your X coordinate is 0 right there. So like your Y axis is here. Or in this particular case, your Y axis is called H of T. So like more properly, I guess we should probably label it H of T. And then the X axis, is it going to be above, below? Is it going to be on one of these lines? Where is it going to fall? It's going to be below. What I'm going to do is I'm going to put me like a little squiggly line here, and I'm going to draw in the X-axis, because in reality, what is the lowest Y coordinate you see on this graph? 6. So really I'd have to go down even further if I was graphing this in proportion to what we have. So it might be helpful here. You've got 5, 10, 15, and 20 for your X-axis, or technically it's T-axis because it tells you H of T equals A sine B T plus C plus D. And then this Y-axis, Y-coordinate of point J is 6. Your Y-coordinate of G and K is 9. And then the Y-coordinate of F and P is 12. So that kind of helps you get bearings on where you are at. Now, there are several things we've got to figure out for this graph. We need amplitude, we need midline, we need to know what the period is, and we got to figure out how we plug that in. We also need a phase shift on this one. Now, and I think phase shift is the most difficult thing to think about. So some of these are easier to find than others. A is just your amplitude. What is our amplitude here? It is 3. Because that would be the distance from the midline up to the highest point. That goes from 9 to 12. All right, so A is 3. I'm going to also skip over B and skip over C and do D. Where's our midline? 9. So D is 9.
Well, is it not Y equals 9?
It's not asking for the midline here. It didn't say what is the midline. You're finding the values of A, B, C, and D. So in this case, you just want to say D equals 9 for that. If they ask you what is the midline, then you definitely want to say Y equals 9. Good question. All right, so I actually think it's probably a little bit easier. Like phase shift is a little tricky. It's not, phase shift is easy to do if they tell you the phase shift is this. If you're doing it from a graph and you don't know what the phase shift is, it makes it kind of difficult. So let's work on that B value right there. So from maximum point to maximum point, what is the period of this graph? It would be 20, right? So is my B value 20? It is not. What have I got to do to find that B value? 2 pi divided by 20, which will reduce to pi over 10. So that is our B value. Okay, questions so far? All right, so I think phase shift is the hardest thing to find. There's a way you could do this where you wouldn't need a phase shift at all. Because your y-intercept is at a maximum. So which function has a y-intercept at a maximum point? Cosine. So if I just did cosine, then I wouldn't have to do it at all. But can I do cosine? I cannot because they told us to use sine, right? So think about what sine looks like. Think about like your really general graph for sine of x. You would have the sine of 0 is 0. And then after that it goes up and then down. So sine looks like this, right? This right here being the midline. So when you do all these other transformations for it, if I have not done a phase shift, so without a phase shift, sine would look like this. I'm gonna do it in green here. This is not my answer. I'm trying to figure out how much I need to shift this graph. It would go to the midline, then at the next point given it'd have a maximum, and at the next point given it'd be back to the midline, it'd have a minimum, and then back to the midline. So if there were no phase shift at all, right here is what you would be dealing with, right? That green graph. So like so far without a C, this is what our graph would look like. We need that graph to be shifted over to match our black graph. Yes?
So like since it looks like cosine, could you just add 2 pi? Or no?
2 pi is a full rotation. So adding 2 pi will not work, but it's pi over 2 because they're off by pi over 2. But in this case, the period is, well, I guess it's okay. In this case, the period is different. So if the period was 2 pi, it would be pi over 2. But the period is different here. So when I shift all these points over this far, everything needs, you could go to the left or to the right, really. It doesn't matter whether you go to the left or to the right in this case. But left is a shorter distance, so it's easier to see. So if I take all these points and shift them over, how far am I shifting them? 5 units, right? Because the x-coordinate here is 0, x-coordinate here is 5. So you're shifting over 5 units. So that C needs to be a 5 right there. And it'll be a positive 5 because it would move to the, that would make it move to the left 5. But would it be okay to also, so you don't want to put both answers. Do not put both answers because that, they're not, you can't have 2 different C's at the same time. But instead of doing C equals 5, could you do C equals negative 15? Right? Because if I took these points and instead I took like that maximum point and moved, on my green maximum point and moved my green maximum point over here to this maximum, that would also have the graph line up, right? And how far is it from here to here? 15 to the right. So we could use negative 15 there. And it doesn't tell us anything else specific that we have to have. So these would be our values that we would have for A, B, C, and D. Okay? Questions there? All right, so while I'm checking homework, I want you guys to try, start with 14, and then go back and see if you can do 13. 13 I think is a little trickier because you got your pi over 2s and 3 pi over 4s and whatnot. So start with 14. It's a little more straightforward on the numbers. So start with that and then try 13. And I'm going to check 14. Now, in this case, your y-axis is not through one of those points because you don't have anywhere where the x-coordinate is 0. So it's counting up by pi, 2 pi, 3 pi, 4 pi, 5 pi. So you have to go backwards pi to know where to put that y-axis. So this point that's not labeled should really be like your starting point for your y-intercept for that. So, and then your like lines here, the bottom one is 20, the middle one's 30, the top one is 40. So we have to find A, B, C, and D. Two of these I think are very easy. The other two are much trickier. What is our A going to be? It's going to be 10. What is our D? 30. For that. Good news is when you see this on the like an FRQ question, it's worth 2 points, and you get a point for getting 2 of the 4. So you would get at least a point if you can come up with those 2, which are much easier to find than other parts. This is from the worksheet that we had the other day, so you already have this. Okay, so what is the period of this function? 4 pi, you guys agree? Right, it ends at 5 pi, but it also only started at pi, right? So you got to subtract those 2. So the period is 4 pi, but that's not what it's asking for. We got to find B. How do we find B? 2 pi divided by 4 pi. Pi's will cancel here. You will get 1/2 for your B. They don't do half points, so I think if you got this, you would still be at 1 out of 2. No, they do not round up. Yeah. So, B's not that bad either, really. Really not that bad. But, you got to get C to get that second point that goes with this. So, the C is where it's tricky. And again, they couldn't make it easy for us because this graph right here has a y-intercept at the midline, and then it goes up and then down. The graph we're looking at, what kind of graph would it be? Would be the easiest one to use. Sine, but did they ask us for sine? No. So now I have seen some of the release questions where C is 0, like where you don't have to do a phase shift. So it's possible. I think that Mr. Passwater probably wasn't putting that on here too awful much, just because it is a lot easier to do and you don't need as much practice with it. And there's probably one where that is the case. Like on 15, your C is going to be 0, because this point right here is 0, 12. There's your y-axis. Y-intercept is a maximum. You're doing cosine, so your C would be 0 on number 15. We're not doing that one right now, but C can be 0, but he didn't put it on here a lot because that makes it much easier. So, if we have to use a cosine function, I'm going to graph what this cosine function would look like if we did not shift it in green. And then we'll look at how far we'd have to move that over. So, cosine has a y-intercept at a maximum point. So you would have maximum, the next point would be midline, then down to a minimum, midline again, maximum, midline, minimum, and so forth here. So your cosine graph, if it was not shifted, would look like that green graph right there. Okay, so you can move it to the right or to the left. I usually just go with whichever one is the shortest distance. So in this case, it helps to look at like maximum points or minimum points because they're the easiest to move. It's a little trickier, like if I move this point right here over here, I have not necessarily moved. Well, yeah. If I take, you really want to think about moving that green graph. No. So if I move this green point right here, I'm good. But if I move the green point backwards, it's still on the graph, but it's not going to be right. So I want to take my green graph, I want to move it over to line up with what I'm supposed to have. So, you know, all these points right here would go this far. How far is that? Pi. So my C needs to be, I'm going to the right, so it needs to be negative pi. Okay. It would also be acceptable to make C positive 3 pi, but don't put both. Just know it's possible, right? So put one or the other. Don't put two answers for that. Okay, questions? Let's take a look at our graph for 13, because I think a lot of you got the graph wrong. So for number 13, you've got pi over 2, 6, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. What are you counting by? Like, it was easy up here. I was going by fives. 5, 10, 15, 20, right? My x-axis was numbered by fives. Down here, it had pi's, but it was still very easy because I was going pi, 2 pi, 3 pi, 4 pi, 5 pi. Very easy. Here, I go from pi over 2 to 3 pi over 4 to pi to 5 pi over 4 to 3 pi over 2. What are you counting by? You're counting by pi over 4, or 1/4 pi. Because from pi over 2 to 3 pi over 4 is pi over 4 is the distance. So what I did here to make that make sense is I made everything a pi over 4. So like pi over 2 is really 2 pi over 4. Then this would be 3 pi over 4. And this would be 4 pi over 4, which reduces to pi. 5 pi over 4 and 6 pi over 4. So my y-axis is not here, but how many like tick marks have I got to count back over to get to the y-axis? In this case, it's not just 1, but 2 right there. And I think when I was looking around, I was seeing a lot of you did not like have that extra part, which means you've even got to kind of extend your graph a little bit there to get that point that you would be dealing with for that. And then your x-axis also runs, or your t-axis also runs through the middle of this graph, right? Because you got some negative y values on this one. So it's like right here. I've labeled it down here. I really shouldn't have done that. I guess I should have labeled it up here, but you guys get the picture, I think, there. For that, obviously, those would go up from there. So, well, let's just go ahead and do this one together. What is our A going to be? 7. Because from -1 to 6, if we subtract those, we will get 7 for that. Or -1 minus -8 will give us 7. I'm going to skip B and C for right now because D is the next easiest to find. What's D going to be? -1. All right, we got half our points now. So, like, if you can do nothing else, you got a point right here, right? Those points are not that hard to come by. So we're not going to miss that point. Next point, we're going to do our best, right? And it's we're going to do several of these. They're always like the same formula for it. So I think you'll be able to learn how to do it and do well on it, but not as easy as A and D right here. So let's look at the period of the function. I like to think maximum to maximum. What is the period of the function going to be? It is 2 pi over 2, because if you do 3 pi over 2 minus pi over 2, you will get 2 pi over 2. But what does that reduce to? Just pi, because those 2's can cancel right there. So my period is pi, but my B value is not pi. What do I do for that? 2 pi over pi. I'll just get 2 for my B.
Oh my gosh.
All right. Okay, now, you do have a couple options here. All right, so you have some options for your C's here because they told us we've got to do a sine graph. Actually, no, No, you got to shift it. If it was a cosine, I could do a negative cosine here, like flip cosine, and I'd get this graph. But it's not cosine. So we got sine graph. So what I think is the best thing to do is just graph what sine would look like. I don't think you are allowed to use like other colors there, but you could, you'll have a pencil. This will be printed for you, so you'll be able to tell which is which here. Yes, this part would be on the free response, and it'll be handwritten. So sine starts at a midline, and then it goes to a maximum, back to the midline, minimum, back to the midline, maximum, back to the midline, and it keeps on doing that, right? So this green graph that I've got right here, it's going to look like this. Easiest to look at, maximum over to the next maximum. What would that be for this problem? How far am I moving it? What? Negative pi over 4. Negative because I'm moving it to the right. And pi over 4 is the distance, because each one of these, that's why I really like labeling that with pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4, instead of the pi over 2, 3 pi over 2. It makes it more obvious how far that is. So you're just going up by pi over 4 each time. We only went like one increment right here, so it's pi over 4.
I know if it's like negative or positive. Like which graph are you looking at?
You want to take, so that green graph that I drew in, this is sine without a phase shift. So what you're needing to do is you need to take that graph that you're sketching in, and you need to move it on top of the graph that's printed. So you want to take the green graph and move it on top of the black graph, not the black graph onto the green. Because what I've graphed here is what sine would look like without a phase shift. So it would be wrong without a phase shift, right? It wouldn't be what we're looking for without a phase shift. So the one you sketch in is the one that you're wanting to move for that.
And it's still opposite, because like you're moving it right, but you need a negative value to do that.
Correct. Right. Still use opposite signs. Okay. Questions? Okay. In general, we are going to be using this formula right here. They might, as we saw on that last worksheet, they might use cosine instead of sine, although sine is the most standard here. So we just really start off here with some pretty basic stuff. So these are not necessarily even modeling questions. They're just making sure we understand what is happening here. So it says let f be a sinusoidal function. What is the period of f? So looking at that graph, we're looking for the period of f. What do you guys think? Okay, 2. So you definitely can go from like maximum to maximum. This looks like it's negative 1.5. This is 0.5. So if I do, always do your highest one minus your lowest one, 0.5 minus negative 1.5. Then that gives me, that becomes positive, that gives you 2. So that looks good for that. You also could think like, if you start at the y-axis, if I trace this till it starts to repeat, if I trace this till it starts to repeat, it starts to repeat right there at 2, so that's your period. Okay? All right, they have given us here a sinusoidal function that is cosine this time. They gave us all the pieces except for c. and we need to know the value of C. So I like to, when I'm doing this, I like to draw in my midline. So my midline would be right here. And the numbers to adjust for the midline and the period and all of those things are going to be correct already, or they wouldn't put it in that way. I kind of need to think about where like my tick marks are. It might help to mark, like you got a maximum, midline, minimum, midline, maximum, midline, minimum. Mark those here. So you're kind of thinking about like you could add some extra little tick marks here on your graph. So if I graph a cosine graph, my y-intercept should be at what? Maximum, midline, minimum. Maximum, right? Because when I'm thinking of cosine of x, cosine of 0 is 1. It's a maximum point. So cosine looks like this. So if I graph that, I'm going to use green like I've been doing. Maximum, midline, minimum, midline, maximum here. Then I can go the other direction as well. So if cosine has not been shifted, so it would look like this. Right? If cosine had not been shifted at all, it would look like that green graph. How far in which direction do I need to shift my green graph so that it would turn into that printed graph there? Okay, I could go with a negative pi over 2, which would move it to the right, or I could also go with a positive pi over 2, which would move it to the left. Doesn't matter which one you use here. They are using positive values, which would move it to the left, and you'll get C for that. Okay, does that make sense? Okay. All right, so this can be used for all kinds of different, like circular motion. So a yo-yo that is attached to a 30-inch long string is rotated at a constant rate. The figure provides the representation of the yo-yo in the XY plane with the direction of rotation indicated. At the time t equals 0 seconds, the yo-yo begins to rotate. The yo-yo is at the start position in the figure at time t equals 5 seconds. The yo-yo has completed 20 rotations when the yo-yo is in the same position as it was at time t equals 0. A sinusoidal function is used to model the x-coordinate of the position of the yo-yo as a function of time in seconds. Which of the following functions is appropriate model for this situation? So I think what we've got going on here, because it's 30 inches, and we've got 30 here, I think that there's a couple ways this could be happening, but I believe what is being described here, so is that you've got a yo-yo, and you have just like let the string out, and you're slinging it around in a big circle, trying to break everything in your mother's house is what you're doing right now. This is dangerous stuff. You could have given the same problem if you've had any of those yo-yos, like where you sling it down real hard and then it just spins at the bottom. It could be the yo-yo itself, but I don't believe it is because it tells us about that 30-inch long string. And if the yo-yo is just like rotating around itself, it doesn't matter if it's on the 30-inch long string. So this yo-yo trick is you just slinging it around in a circle. Knocking your little brother in the head, knocking off a lamp and a vase and everything else that's happening here. It's a reckless problem. My boys got yo-yos for Christmas. Hunter's Hunter's working on it. He's pretty good with the yo-yo. He's got some skills. And my husband, he got one too. Well, the boys got one and he liked it, so he ordered his own yo-yo. And so they have been practicing they haven't in a while. At Christmas, they were really practicing their yo-yos. But we went to, at the Quiz Bowl competition on the homeschool team. It was the little boy that works at Chick-fil-A. Probably. That sounds right. He had a yo-yo, and I realized Hunter's really not that good at yo-yoing, because that kid must just sit around yo-yoing constantly. Yeah. Yeah. Yeah, I thought they were.
He's older than me.
Yeah. 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 Yeah, he is. But did you see him yo-yoing at the Quiz Bowl? It was impressive yo-yo skills. Yeah, like, oh yeah. I videoed it. I'll show you later. Yeah. I videoed it so I could send it to Hunter and be like, you need to get your yo-yo skills up to this level. Yeah. Yeah. It was impressive yo-yo skills. I've not seen any except for on TV. But that's not relevant to this problem. So, in this case, our yo-yo is slinging around, and it tells us at time, we know about t equals 0, we know about something about t equals 5. The yo-yo has completed 20 rotations in the same position when yo-yo has completed 20 rotations at time, okay, so start position. At time t equals 5 seconds, the yo-yo has completed 20 rotations and is in the same position as it was at t equals 0. So 5 seconds, it's gone around 20 times. You really slinging this yo-yo with all of your might. It's just getting worse and worse. Okay, so 20 times around. We need to think about, like, 5 seconds was 20 rotations. We only really care about, like, 1 rotation, right? Because we want like a period of the function. So it was 5 seconds for 20 rotations. We really want to know about 1 rotation, because 1 rotation is going to be like a period of the function. Okay? How long is that going to be? It is a quarter of a second, because if we take, it took 20 rotations in 5 seconds, then that would be, well, I really should have written that the other way. 5 seconds for 20 rotations, then that is going to be 1/4 second per rotation. There. So 1/4 of a second. This is your period of the function. So this question is really only asking you about period, because notice they all have the same amplitude, or not really asking you about period, it's asking you about the B value. They all have the same amplitude. They have different values on the inside right here. So remember that your period is not your B value. How do we find that B value? 2 pi over the period, and dividing fractions is easy as pi. Flip the second and multiply, and you got 8 pi. So D is the right answer.
What's the T value?
T is your variable here. Because in this case they're using time for the variable. Okay, questions? Okay, I also understand that some of his applications are not necessarily ones that you would calculate per se. Like you wouldn't necessarily care about this yo-yo that you're slinging around. But if you apply it to something more important, if it is a part in a engine, like the one I use this one for Math 3 sometimes. The very first Ferris wheel that was ever made was gigantic. I read a book about it. The book was it was a really interesting book because it was called The Devil in the White City, and it followed like the Chicago World Fair in like 1890 something, and there was a serial killer that was like killing women and had a crematorium in his like apartment buildings that he owned, and he was like, it was crazy. So it followed like parallel stories. The World Fair was also a little bit of a like disaster because like they didn't get things built in time, things messed up. Ferris wheel was a big part of it. The Ferris wheel was built for the World Fair.
They those two stories together.
Yeah, it like went back and forth because it like all happened at this. It was all happening at the same time, so it was at the same place. I mean, it was all during the Chicago World Fair. So yeah, The Devil in the White City. It's a little dark, but it was one that I like. I mean, and it's I'm sure he has written it as a story, but it's not made up. It's based in fact. Now he might add in a few little extras, to make it a little, more flair. But no, it's sort of omniscient. You can, and so anyway, it was a very interesting book. But one of the most fascinating parts was the Ferris wheel, because the Ferris wheel was built, and the first Ferris wheel we ever built. I wish I could remember the exact number. I've got it written down on my Math 3 stuff. It was like hundreds of feet tall. Every car held 60 people, and it had 24 cars. Like, this Ferris wheel could hold 1,000 people at one time. And in the car, people were just standing in the car. There was like 60 people in there standing in the car. It had like glass around it, and it went around. And, they didn't know if it was even going to work. It was powered by a steam engine. Like, we barely had electricity. One of the big draws to the Chicago World Fair was that they had electric lights. They had light bulbs. Yeah, so it was crazy to think. And it talks about when they turned it on, they didn't really know if it was going to work, but they didn't have the cars on it yet. And so the first time they turned it on, some of the workers just grabbed onto the bars and rode it all the way around 300 feet in the air. Just holding on. At the time, it was almost as tall as the tallest skyscraper that we had, because our skyscrapers were 12 stories high.
Right.
So, it's really a crazy idea to think that we, I'm sure they made some small scale models. You could put them on top of a table sort of models. But they did not build let's try 20 foot tall, 30 feet, 40 feet first, and then try. They just yeah. I think it was a very different time, for sure. So anyway, it's interesting. You should check it out. But calculations on that, it was like a big engineering feat to make that happen. So something like that, it might be much more important to model than when you're slinging a yo-yo around your house recklessly, And there could be a lot of different things. I imagine those giant windmills that they have for power. You could talk about those. I imagine that you might need to calculate some different things dealing with that, like how fast that blade is spinning, what it's turning. Those would all be sine functions because the height of that blade is just turning, there. So anyway, these are a little silly. There are some places I'm pretty sure it can be applied in a more serious manner, but to do it well, you probably have to have data that we don't have. So we got a clock mounted on the wall up here. Tip of the minute hand of the clock is what we're looking at, where we've got this information. H of 0 is 70. H of 30 is 52. And this, our T, they don't specifically say what T is measured in, do they here? But they should have, because it makes a big difference. Yeah, it's the minute hand, so they should have said that T is minutes here, because it could be like T is seconds, and that'll totally change everything by like a factor of 60. But T should be in minutes here. So at time 0, we got 70. At time 30, we've got 52. And so in this case, 70 is our highest and 52 is our lowest, right? So 52 is your lowest because the clock is on the wall and it's not touching the ground, right? It doesn't go all the way down to 0. So if we think about trying to make a graph for this, at 0, we've got, actually, hold on. I don't really need that. Let's draw, I'm going to put the axis way down here, because right here we got 70, that's our maximum, and then we got, let's see, we got 0 here at 30, we got 52, I'm not drawing this to scale at all, we got 52 right here, that's your minimum, and then, so at 60, where are you going to be? What's the height going to be at 60? It's going to be back up at 70 because it's going to be back at a maximum because you'll have one full rotation in 60 minutes, right? And so you're going to have a midline right here. Where's that midline going to be? Okay, midline is 61. How'd you get that? Right, average. Sometimes the numbers are easier to do than others, but you can always just add together, divide by 2, right? That'll average those two numbers and give you your midline. So if you average your maximum minimum, it's going to give you your midline. So actually, if we're going over here, A, B, C, D, 61 is my D right here. And so this is what my graph will look like. It might be a good idea, like where we hit that midline right there, it might be a good idea to label that. What's that going to be? How many seconds is it going to be at like the midline? It'll be halfway between 0 and 30, right? So this will be 15. This right here will be 45. So we're looking for a graph that looks like this. The easiest thing to have done would be to use which function? Cosine. But did they use cosine? No, because obviously they don't like to do things the easy way. Because if this was cosine, we would not have to shift it left or right at all. Let's go ahead and do A first, though. What is A going to be? 9, right? Because 70 minus 61, or 61 minus 52, those will both give you 9. What is the period? Oh yeah, it only asks us for A and D. So I guess we're done. I made it too easy. The period is 60. B is 2 pi over 60, which is pi over 30. And then a sine graph would look like this. I'm finishing it anyway, but you are correct. sine graph would look like this green graph right here. How far does it need to get shifted? It needs to go 15 to the left. Oh gosh. If you go 15 to the left, you really are dealing with... Yeah, I think we're okay. 15. Yeah, so we would have 15 right there. Okay, questions? All right, let's look at the next one. We've got, this time it gives us an equation that gives the average monthly temperatures in degrees Fahrenheit in a town in central Indiana. And for this, you've got 1 through 12 is where you apply this, being January through December. So, based on the model, which of the following is true? So, A says the maximum average monthly temperature. And don't let that word average fool you, because we're talking about the average monthly temperature for each month. It does not mean the average of all of the months whenever we see that. Maximum is 61.2. Is that correct? That is, 61.2 is my midline. So no, that is not going to be it, because 61.2 would be the midline. So that's not going to be maximum nor minimum, right? The maximum average monthly temperature occurs at M equals 1. Let's look at the others first before we worry about that one too much. It's a little harder to think about. It says the minimum average monthly temperature is 35.5. How could I find the minimum without actually like having to graph this? 61.2 minus 25.7, which if I borrow right here is going to give me a 5 right there. Borrow again, 5 right here, 35.5. Does that look correct? That looks right. To talk about where those average monthly temperatures are, we would need to think about what the graph kind of looks like. Even if you don't really worry, just think about this being the midline. It is a sine graph, so it would be like if we label this 1, 2, 3, 4, 5, 6, 7, and so on. Like sine would start at here, and then you would have like maximum, a full period would be 12 months, so you know at 3 you'd be at maximum, then minimum like that, but it gets shifted to the right 4, so right, this would go right 1, 2, 3, 4. That maximum would be at 7, but this says minimum. The maximum's not going to be at 1 because that maximum's going to be at 7. It can't be at both places, which makes sense. Also, just think about what you're talking about. Are you going to have your maximum average monthly temperature at 1? Because 1 is which month? The first month, which is January. Are you going to have maximum average temperature in January? No. And you're also not going to have minimum in 7, which is July, right? So unless you're in the southern hemisphere, right, it would be backwards if you were southern hemisphere, but if you're in the northern hemisphere, that wouldn't happen. So you can also think about just what you know logically about these things here. Okay, this one, here, we've got data numbers, but based on those answer choices, I want to say Well, I don't know. Feels odd that those are off. Let's do it with a calculator first. I'm going to just pull up Desmos here. It's not much different than what we have done. So you don't have to get your computers out just for this one problem. But if we enter our data real quick here, we got 1. Oops, thank you. Yeah, gotta keep me in line here. I don't know, this one might have to be a calculator problem. It's just odd that it is, it's odd that it is so, the answers are so nice right there. I think they could give you a table that you do the whole thing by hand, but I think they'd give you more even increments right here where you can clearly see, oh, we hit the maximum, then we hit the maximum again. I don't think that it's going to be the case here. So I think they are wanting you to use a calculator. Let's see if it's got the sine regression here. Sinusoidal regression. All right, you need to be careful with this. We really don't want to use the sinusoidal regression. The reason that we don't is because, right here, let me zoom in a little bit. Right here, what's different about this than what we see right here? Actually, no. I take that back. It is the same. But this is different than what we've been using for the other stuff, right? We had an extra set of parentheses there, so be careful with what, like, form that you have. I need to go look at the, well, the free response is not going to have to be calculator active. So this would have to be a multiple choice question where they'd be asking you to do this. So in this case, we have a graph. It says, what is the maximum number of nighttime hours predicted by the sinusoidal function? So if you're doing this with the graph right here, it is so super easy because all you need to do is click on that graph right there, find you a maximum, and there it is going to be. I guess they have rounded these answers to a whole number, although he didn't tell you. I don't love this question, Mr. Passwater, although I still appreciate you doing this for me.
A restriction like 1 to t as well. Can we go past?
You're right. We probably shouldn't go back. It's repetitive, so it should be the same for all maximum points. So it shouldn't matter, but we probably should not go past 12, but we should get that same value we should get that same y value wherever we are at. So
Just look at the table, because like 11 like repeats itself.
perhaps that is what they're wanting us to do. I don't like this question. I just don't like, because he didn't tell you to round. There.
Oh, well, maybe it's
Although,
like,
Mr. Passwater,
it's like hours,
I still appreciate you for making all these worksheets. They're mine. I would, yeah. But the question, there's not, I just don't like that I would go with 11, but maybe you round up. But even if you're using the table, you still have to round. So, I don't love this question. But we've seen how to do it here. All right, so we got a few minutes for you guys.